Flocculation is the process of encouraging small particles in water to stick together so they are easier to filter out. Improving flocculation improves filtration, which brings clear benefits for customers. First, filters are easier to clean because debris collects on the surface, rather than becoming embedded. This means backwashing, flushing water backwards through the filter to remove dirt, requires less water, so less fresh water needs to be added. In swimming pools or jacuzzis, this saving is especially important, as any replacement water must be treated and reheated if the system is heated. Using less water therefore reduces both water and energy costs. Second, easier cleaning reduces downtime and maintenance. Third, in applications like wastewater treatment, the largest financial saving can come from reducing chemical flocculants, which are expensive consumables. Extending filter life and lowering pumping pressures can also help, but the main advantages are water savings, reduced maintenance. There are a few important things to keep in mind when working with flocculation. Flocculation only happens in the water that passes directly through the unit. It does not spread through the system in the same way the limescale signal does. Turbulence is needed. Mixing in the water is what brings particles into contact so they can stick together. Time is also important. In practice, this means providing enough pipe length after the unit to allow collisions to occur. Pumps are very useful in this process. Almost all systems with a filter also have a pump, which creates exactly the turbulence needed. For that reason, the unit is usually installed upstream of the pump, ideally with some distance to allow more time for flocculation. Filter operation matters. Backwash timing, automatic controls, and general maintenance practices all affect results. These factors are outside the scope of HydroFLOW itself, but they influence how effective the overall system will be. Looking at the bigger picture is important. The next example comes from Sargent Farms, where the challenge was treating what is known as red process water. This water contained a large amount of organic material, making it difficult and unpleasant to manage. The site used a dissolved air flotation system. In this process, the water is pumped into a tank, while air is bubbled up from the bottom. The bubbles carry the organic matter to the surface, where it forms a foam layer that can be skimmed off. Normally, chemical flocculants were added to make this process work effectively, but they were costly and needed in significant amounts. After installing HydroFLOW, the site saw results within an hour. The amount of chemical flocculant required dropped by 25%, and the separation process worked more efficiently. Compared to limescale or biofouling treatment, which often takes weeks for the effect to become clear, the benefit in this case was almost immediate. Another example comes from a sewage treatment plant in the UK. Once sewage has passed through the biological treatment stage, there is a point where solids must be separated from the liquid. This step is called dewatering. The solids, referred to as cake, can be taken away and used as fertiliser on farms or fields. The liquid is processed further and eventually returned safely to rivers or back into the water cycle. There are a few ways to carry out dewatering, such as belt presses, screw presses, or centrifuges. In this case, the site used a centrifuge. It spins at high speed so that solids are flung out and the liquid is released. To make this process work effectively, a polymer flocculant, often called poly, is normally added. The poly helps the solids stick together so they form a stronger cake that separates more easily. With HydroFLOW installed on the centrifuge line, the polymer dose was reduced from 3.6 kilograms per tonne of dry solids to 3.2 kilograms. That is a saving of more than 10%, which in this type of application is a significant financial benefit. The improvement was visible as well as measurable. With HydroFLOW on, the cake came out firm and able to hold its shape. As a test, the operator switched the unit off. Within 25 minutes, the material became runny and the overflow alarm went off, showing the direct impact of the signal on performance.